So I'll start recording the class. So here we want to look at how to write the electronic configuration of elements. Okay, we've learned before now that we have this sublevel SPDF. S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. We've learned that. Okay, now pay attention. Now, before we move, observe this pattern that we have. Here we can have 1s, here we can have 2s, here we can have 3s. Pay attention. Here we can have 4s, here we can have 5s, 6s, 7s, and so on like that, unlimited. Why here? The rule you have to understand is that this P starts from 2. So you have 2P, 3P, 4P, 5P, 6P, 7P. D starts from 3. If you observe the pattern, you see, I have 1s. Yeah, I don't have 1P. No, I don't have what? 1P. I don't have 1P. If you have been asked why, remember that in this first energy level, n equal to 1, it was only S you have there, not P. So just take note from here that I just have this on 1s. Here I have 2P. Here start from what? 3D. Let's go 3D, 4D, 5D, 6D, 7D. Orbitals like C. Orbitals like 1P, 1D, 2D do not exist. This type of orbitals do not exist. Take note of that. Those orbitals do not exist. Good. So this one starts from 4. I've done 3D. This one starts from 4. 4F, 5F, 6F, 7F. Take note that orbitals like 1F, orbitals like 2F and 3F, those orbitals don't exist. Don't forget, orbitals that don't exist is 1P, 1D, 1F, 2D, 2F, 3F do not exist. But all of that ones can exist. So this is how we do it. We first start writing from 1S. When 1S is occupied, we move to 2S. When 2S is occupied, we move to 2P. When 2P is occupied, we move to 3S. Next, we move to 3P, then to 4S. When that is occupied, we move to 3D, 4P, 5S. After that, we move to 4D, 5P, this. After that, we move to, just trace this line. We move to this. After that, we move to this. After that, we move to this. And lastly, we have this, and so on like that. So let's start from the first element that we have. Okay, let's start from hydrogen. So we have hydrogen, atomic number is 1. So let's go. What do we have? Remember, it has 1 electron. It has 1 electron. And remember, which one am I starting from? I must start from 1s. Are we together?
Yes.
So it's when 1s is occupied, you are now going to the next one. So we have 1s. So this is what 1s. 1s. And remember, we have 1 electron to fill. So we just put that 1 electron on this 1s1. And that is it. Do you get that?
Yes.
So let's learn how to write it before we learn how to draw the diagram. It's very important. Let's learn how to write before we learn how to draw the diagram. So number 2, we have helium. Helium, He. That is electron, 2 electron. So let's go. I have 1s. Now check, how many electrons do I have here to fill? 2, right?
Yes.
Because S can accommodate 2 electrons, I just have 1s2.
Okay.
The next one, I have lithium, which is 3 electrons. Remember, we start from 1s, but it is a blunder for me to say 1s3. Do you know why?
Because S only has 2 electrons, can only accommodate 2
electrons. So I say 1s2. So since this 1s is occupied, I'll move to the next one, which is 2s. So the last electron I'm to fill, it will be here. So if you observe, 2 plus 1 will give me 3. That's it.
Oh,
so I'm something like that. Do you understand? Any question? Any question?
So when do we now start using P?
It depends on the element. Let us move on.
Okay.
Let us move on. Let us look at beryllium. which is number 4. Let's go. I have 1s2. I've used 2. I have more 2 electrons, so I'll go to the next one, which is 2s. 2s2. 2 plus 2, that's 4 completed. So number 5. Let's look at boron, which is this, number 5. So I have 1s2, 2s2. Now, if you observe, I have 1 more electron. If we check, what is here is 2 plus 2 is 4. I have 5 electrons to fill. I have 1 more. Where do I put that 1 more?
3s.
Remember, I think that this and this has been occupied. Where will I move it to?
3s.
Never. No. Check it very well.
2p.
From year to year. All together. So where am I?
2p.
I'll first occupy 2p before 3 years. Okay, is that clear?
Okay.
Exactly. So I'll say what? 2p1. All together?
Yes.
Now, pay attention. There's something they want you to understand according to IB diploma. What they want you to understand, pay attention. You have to understand that you see these elements that end with S, that the electronic configuration end with S from year to year. This element belong to S block in the periodic table. They belong to which block? Hello, they belong to which block? S block.
S
All together? Why?
Okay.
Because they end
Because
in
they are all
S
S's.
sublevel. All together?
Yes.
Why this one that end with P I'm putting here, or all other ones that end with P is in P block? Is in what?
P block.
P block. Good. So I've given you the foundation. Now let us now go to more elements higher than this. So I want to go to some element higher than this. Okay, let's pick these elements. Okay, give me elements. Maintain the first 20 elements for now. Give me elements. Let's go. Can you tell me? Oh, yeah.
Helium, lithium, beryllium, boron.
Give me element from. Are we together?
Yes.
Give me any elements. Yeah, mention any elements in it.
Carbon.
What is it?
Carbon.
Carbon. Okay. We are looking at carbon. No, give me another one. I want something bigger than. Okay, let me say we are looking at magnesium. Magnesium is number 12 in the periodic table. If you give your first 20 element, you will see. Magnesium is what? Is number 12. All together.
Yes.
Okay, let's go. What do we have? We have 1s2, 2s2, and my 2p can accommodate 6 electrons. Don't forget P. 2p 6. If you check, I've filled how many electrons? 10, right?
Yes.
6 plus 2 plus 2, that is 10. And I'm going to 12 electrons. So let's go. It means that I need 2 more. Where will I put that 2 more? Check. I've occupied 1s. I've occupied 2s. I've occupied 2p. The next one is what? 3s. All together.
Yes.
So I have 3s. 3s what remains? I have 2 electrons remaining, and those 2 electrons can accommodate here. So I have 3s2. So here that you're looking at belong to S block. S what?
Block.
S block. All together.
Yes.
All together.
Yes.
Okay. All right. Let's look at another one. Let's look at argon, which is number what? 18. Let's go. What do we have? Check it out. 1s2, 2s2, 2p6, 3s2 occupied. After 3s2, I'm going to 3p. Follow that line. I'm going to 3p. So I want to occupy. See, if I occupied everything, how many do I have? Check. 2 plus 2 plus 6. I have 10.
10.
Plus 2, 12. Plus
12.
6. How many? 18, right?
Yes.
Good. I have what? 18 electrons. So this is what this is completed. So is at the P block. So at the P block. All right. We have done them. Okay. That's how to write electronic configuration. Now pay attention. We have some short notation. That let me call this condensed electronic configuration. Condensed electronic what? Configuration. Now pay attention. Have you seen the periodic table before?
Yes.
You see, we write condensed electronic configuration based on our group 8 elements on the periodic table. You see our group 8 elements. Pay attention. Our group 8 or group 0 elements. We have helium with this electronic configuration 1s2. We have neon number 10 with this electronic configuration. Remember 1s2, 2s2, 2p6. That is 10. We have argon with this electronic configuration of the one we just did now: 1s2, 2s2, 2p6, 3s2, 3p6. So we have all these. Now pay attention. You will see how we write condensed electronic configuration. Now give me any elements. Let's say we have magnesium. Are we together?
Yes.
Magnesium has atomic number of number 12. Now, just write the normal electronic configuration, the one I just wrote now: 1s2, 2s2, 2p6, and 3s2. That's 12. Have you now?
Yes.
Now, you will see how to write condensed electronic configuration. It's very, very simple. Now, can you tell me which of the noble gases have this electronic configuration that is there? That's exactly what is there. Look at this. Which of those group 8 elements called noble gas? Which of them have this exact electronic configuration? Look at this side and tell me your answer. Which of them have this exact configuration?
1s2, s2p.
Yes, 1s2, 2s2, 2p6. Which of the noble gases? Check here. You see it now.
Neon.
Neon. It means that instead of me writing this, I can just write neon, Ne in bracket, and I just have 3s2. And this electronic configuration.
That's smart.
I'm done. That's very simple. Let's look at another one. Let's look at if I have calcium, which is number 20. Observe. Let me write the electronic configuration for you. And if you follow that pattern, you get it also. 1s2 occupied, I move to 2s2, 2p6, 3s2, 3p6, 4s2. If you observe, as I'm done filling one, I'm going to the next orbital. So if you observe, is this up to 20? 6 plus 4, that's 10. Another 6 plus 4, that's another 10, making 20, right?
Yes.
So how do we now write the condensed electronic configuration of calcium? See that one, this one is too long. It's too long. So how do we write it now? Pay attention. Which of the noble gases have this exact electronic configuration that you see here? Which of them? Is it helium, neon, or argon? What's the answer?
20.
Which of them have this exact configuration? Check.
Argon.
What is it?
Argon.
Argon. So it's means that instead of me writing, stressing myself to write this, I will just say what? Argon, then 4s2. I'm done. All together?
Yes.
Exactly. That's how we write it, condensed electronic configuration. And that's that. So if I tell you that you should identify these elements for me, what's this element? What element is this? Check. Which element is this?
Calcium.
This is calcium.
Is that 2 or 1?
This is 1.
Oh, that's 1. Then is let me see.
Okay.
Potassium.
Potassium. Thank you very much. This is potassium. Do you now see that this is very interesting?
Yes.
Potassium. So we are done with this part. Now we can now write electronic configuration easily. I'll still be writing it for you. Just learn. I'll go and practice all this very well. To make it easier for you, you can just as well just memorize this part, these ones that follow each other. 1s2, 1s, 2s, 2p, 3s, 3p, 4s. You will observe it from here. You observe it from here. See, 1s, 2s, 2p, 3s, 3p, 4s. And last, you can just know 3d. So these are the ones that you'll be using. Usually. So that's it. And it increases this way. It increases this way. And so on like that. So that's that for that. Understood? Understood?
Yes.
Okay. Let us now move further to something. Okay. I think I should stop on the writing on electronic configuration. Maybe in my next class, we will now talk about the drawing of the orbital diagram. Is that clear?
Okay.
Yes, and I'll give you some exemptions to this electronic configuration. There are some exemptions that we have to it that you have to know. So you are going to be learning that. So before we go, let's look at something like this. Look at this question. Okay. If I say write the electronic configuration of of Al3 plus of this ion. Now pay attention. This is the last one we are doing. Don't forget that what aluminum itself has 13 number of electrons. Are we together?
Yes.
But it has lost 3 electrons now. So it means that what I'm having here has 10 electrons, okay?
Yes.
So we are going to be writing the electronic configuration will now be what? 1s2, 2s2, 2p6. You can see that this we are going to be writing for this 10 and not this 13. And you observe that this thing that you're having here is the electronic configuration of neon. Electronic configuration of what? Of neon.
No.
Look at it here. It's the same thing that you have exactly. So what you have here is just like this. So that is it. So we are going to stop at this side. Do you have any question to ask?
No. Oh yes, I do.
Do you have any question to ask?
Yeah.
Okay, ask.
Basic on like since I'm on holiday, I have a job and like my job is from 11 a.m. My job is from 11 a.m. to 5 p.m. So I'll not be able to do classes by 5 p.m. on Fridays anymore.
Okay, please hold on. Okay, that is like not based on this class. So let me just stop this recording and then we discuss that. Okay.
Okay.